By the end of the class, we're going to be able to determine maximum minimum values of trig functions. Let me remind you of some identities that you should have learned in advanced functions. Things like the cosecant, secant, and cotangent. These are what are called reciprocal identities. The quotient identities, one of which we just talked about, that tan was sine over cosine. Cotangent, of course, is cosine over sine. The Pythagorean identities, we also use that when we were coming up with the derivative for tan. Works to be sine squared plus cos squared equals 1. Then there are some addition and subtraction compound angle formulas, and then there are the double angle formulas, sine of 2x, the cosine of 2x, etc., etc. So these are things that you may need to use when you're solving these trig, kinds of derivative questions. For instance, find the absolute extreme values of each function on the given interval. Usually, when you have, Sarah, your Wi-Fi code. Okay, good. Usually, when you have questions like these, they give you a defined domain. So we're not saying where is the extreme value globally. We're saying where is the extreme value between these defined endpoints, between minus pi and 2 pi. So pay attention to that. Right? And think back to when we're doing optimization or extreme values before, where sometimes extreme value was actually on the boundary. So that's why it's important to pay attention to that. Okay, so we know that when you're trying to find extreme values, you need derivatives. So we're going to go ahead and take our function, y equals 0.5x plus sine of x. We didn't have any tools for us to get extreme values for something like this before. We know that the sine x function goes up to 1 and goes down to -1. We knew that, right? And we knew that if there was an amplitude, that would affect how high it went and how low it went. We knew that. And we know if there's a center line, a vertical displacement, what's the word I'm looking for now? Vertical translation, that we'd have to include that when you're trying to find the max and the min points. But what if it was a mixture between, for instance, a linear function and a sine function? What do we do then? Well, now we know that we can use calculus to do that. So let's go on and find, first of all, what the dy dx is of this. So it's a sum of two things. So all we have to do is take the derivative of each part. The derivative of 0.5x is just 0.5. The derivative of sine is cosine. That's simple. Okay? So what we're going to do now with this dy dx is we're going to set it equal to 0. And setting it equal to 0 does mean that the cosine of x is equal to minus 0.5. That is just using regular algebra. This set equal, and I'm skipping a step here. We're setting this equal to 0 by saying that the cosine of x is equal to minus 0.5. Now, the way I do this, and I teach this maybe differently from some other teachers. So if this is the first time you're in my class, which is most of you, right? It may be not the way that you learn to do it, but here's how I do this. I call this x prime. X prime doesn't mean the derivative of x. X prime just means I'm going to find the cosine to the -1, not of negative 0.5. I want to find cosine to the -1 of positive 0.5, which works out to be pi over 3. So my x prime is actually pi over 3. So what I do next is I create a grid, a Cartesian grid, and I put that pi over 3 in the second and third quadrant. Can anybody suggest, and if I've taught before, you probably know exactly where I'm going with this, but can anybody suggest why I put these two rays in the second and third quadrant? Can anybody help me with that? Why am I putting, and by the way, the pi over 3 I'm talking about is the angle that you measure from this ray down to the x-axis, right? Always to the x-axis. Does anybody know why I put those two in those two quadrants? Anybody? Anybody in the room know? CAS rule. Thank you very much. Let me remind you what the CAS rule says. CAS rule says that cosine is positive in this quadrant, and I don't want cosine to be positive. I want cosine to be negative. That's what this line here is saying. I want cosine to be negative. They're all positive in this quadrant. Sine is positive in this quadrant, which means that both tan and cosine are negative. Tan is positive in this quadrant, which means that both sine and cosine are negative. Okay, so I need to have a pi over 3 away from the x-axis in this quadrant and in this quadrant because that's where cosine is, in fact, negative. So it means that I have this answer. Why is that answer? Because I'm now going in a negative direction to get that. Remember, this thing said go from minus pi to 2 pi, right? And if I'm trying to get to this position right here, I can go in a negative direction. That's what this says, negative pi. So one of my values of x is minus 2/3 pi. I'm not all the way at minus pi yet. So this angle right here is minus pi. But I'm not going to go all the way to minus pi. I'm short. These angles inside here are pi over 3. That's pi over 3 there. And that's pi over 3 right here. So to get to pi over 3, I can go in a negative direction, a half a turn, which means that I wouldn't get all the way to minus pi. I'm short by pi over 3. So one answer is the answer I just gave, which is the minus 2 pi over 3. Another answer I can get by going in a positive direction, which is use a rotation going this way now. And I can get to here. And that answer would be 2 pi over 3 and 4 pi. Those answers, I should say, would be 2 pi over 3 to get to this position right here. And 4 pi over 3 gets me to this position down here. And I know that this is all going back to solving trig equations. So unfortunately, or fortunately, if you're really strong at it, then this will be something that you will be either comfortable with or not comfortable with, but you really do need to get comfortable with it to be able to answer these questions. So these are my 3 angles that I am talking about, where the function has a horizontal slope, right? Or a horizontal tangent, or a zero slope, I should say, or a horizontal tangent. So there are 3 values at minus 2 over 3, 2 pi over 3, 2 pi over 3, and 4 pi over 3. Is there anybody who needs me to go about that again in any detail? Or is this ringing a bell from when you were in advanced functions? Can I repeat? Absolutely. So the way I do this, the way I taught this, Taj, is to say, look, let me go back to this point right here. I'm assuming, I shouldn't assume, but I'm going to ask. Let me ask. That cosine of x is equal to minus 0.5 makes sense to you, Taj. Does that line make sense? Let me just put a little box around that line right there. That's my starting point. You're okay with that? Okay, fine. So my question is now, what values of x will give me a minus a half is basically what we're trying to get at this point. So I need to first of all figure out which angle gives me positive a half is the way I do it. Not negative, but positive a half. So if you go to your calculator right now, Taj, right, go take your calculator. And I don't know if your calculator is like mine, which gives you exact values. Hit your shift key or your second function key, whatever it is on your calculator, and hit cosine and 0.5. All right, on my calculator, I'm getting pi over 3. Are you getting that on yours? And everybody else should be trying this for themselves. But you should be getting pi over 3. Tell me if you're getting that on your calculator. No, it's not giving me an exact. Okay, so maybe it's not on yours, but please understand that it is the same. It's equivalent to pi over 3. Let me see if are you getting 1.047, something like that? Is that what it's giving you, Taj? Is that, I just want to know, it is. Okay. There may be a way for you to give an exact value. I don't know which calculator you have, but some calculators do give you exact values. What about the rest of the class? What's your experience with this? The truth is that you can use your special triangles to get this information. And I can't really go back and teach that right now, but it does come from the special triangles. Danny says exact value on his. Okay. You have a Casio, don't you, Danny? Actually, I don't know that. It couldn't. It doesn't have to be. It doesn't have to be a Casio. It's not only Casios that do that. But I don't know if most of you have calculators that give you exact value or not. Yes, yes, you do. But if you don't, then maybe use those special triangles to get it, right? I'm not even getting the right, but okay. So, okay. Let me ask you this then. You're pressing the inverse function key on your calculator, right? And first of all, are you in radians? That's the first thing. Oh, okay. So let's do that first. Let's get it in radians. And it depends on the calculator as to how you do that. It's important that you're doing this in radians. All right. Is there anybody who needs some help with figuring out that pi over 3, that the x, what I call x prime is equal to pi over 3? Anybody need some help with that? Because if you do, we can pause for a minute and give you a little hand with that. Or is everybody okay? Is everybody actually trying this for themselves? Because that's important that you're trying this out for yourselves. Okay, so I now have 3 potential places where this function can be at a max or at a min. 3. Yes, can you show us the online? I can. I certainly can do that. I'll have to stop the recording to do that though. So I'll have to stop the sharing at least, but I can keep the recording going. Yeah, okay, let me stop the sharing for that. And let's do this. So I kept the recording going, but I am going to stop the sharing because I need to share my calculator with you. Okay, so I'm hoping everybody can see the calculator. Just confirm for me that you can see my calculator, my virtual calculator, that is. Okay, so on this calculator, it's a Casio. Right now I'm in degrees, so I'm actually going to change that. Shift setup, and I want to get to radians. I'm going to change that to radians. So now I'm in radians, and I'm going to say shift and cosine. See cosine to the -1 in my calculator, and I'm not putting in negative, as I said before. I'm going to put in positive a half, so 0.5, close my bracket, and there's my essentially 1/3 pi over 3. Okay, so you can try that on yours. Now, if I put in cosine to the -1 and minus a half, it worked now. Okay, great. If I put minus a half in, sometimes people aren't really sure what that means, and that's why I always put a positive in. Let me put the minus a half in and see what comes up. Okay, so it gives me 2/3. So you might say, okay, yeah, that's one of the answers, but how do you get the other answers? So I always say to students, never put in the negative because that doesn't necessarily, it may give you one of the answers, but we actually have 3 answers that we need to get. And I prefer to put in the positive, figure out what quadrant I need my answers in, and then go from there. That's how I have always taught this. So did that help you out a bit, Taj, in terms of getting that on your own calculator? Right? And Adam as well. Does that help you out a bit? Okay. And Taj, how about you? Are you good now? You're good? Okay, so I'm going to stop sharing this. I'm going to go back to what I was doing before, but I need to, hang on a second. I'll have to edit that part out. Just give me a minute here. Okay, so we're back to where we were before, and we're going to go from the current slide. Get all my stuff back. And those are my answers right there. All right. So are those the answers? No, those are not the answers. Because the question asks for the extreme values of the function, which are all y values. So I need to take these x values and I need to put them into the function itself. Now, the extremes, the possible extremes are at minus pi, minus 2 pi over 3, 2 pi over 3, 4 pi over 3, and 2 pi. Please remember that when we were doing this before, this is how we did it. We found where the, well, I guess you could call them critical numbers now that we've done critical numbers. where the critical numbers are, and we also have to evaluate the function at the two ends, at the minus pi, right? Because the two parts of the domain, minus pi and the 2 pi are the two ends of the domain. So we have to actually evaluate all of these. And this is what it works out to be. 1 minus 1.57, 1.91, 1.91, minus 1.23, and 3.14. So it means that the max value is the 3.14, which I'm sure you'd recognize would be the pi, and the minimum value is minus 1.91. Okay? We just simply have to put all of these numbers now back into the original function, right? The original function. And when you put that in and evaluate it, you just simply inspect the numbers, see which is the biggest number, that's your max, see which is the smallest number, that's your min, and you're done. Okay? I'm not asking for exact values at this point. I'm just asking for the values to be in some decimal. And in this case, it worked out to be 2 decimal places. Okay? All right, let's move on. Unless anybody wants me to look over any part of that, I'm going to move on. Similar question, minus sine x plus cosine of 2x, going from minus pi to pi again. We still have to pay attention to over what domain we are looking for this. So let's start off with the derivative. It's just a sum of two things, so we take each derivative separately. That's going to give us minus the cosine of x, plus the minus sine of 2x times 2. Okay? All right? So you're thinking, setting these two things equal to each other. Sorry, well, not yet, but let us set this equal to 0. And it works out to be that you can factor out the minus 2, common factor. And then you can, out of that now, here's the thing that, again, you need to remember. I want you to look at this term right here, sine of 2x. There is a trig identity for that. Right, I can take you back to one of the first pages that we had. I'll take you back for a second. On the very first page, oh, this is a lot of going back here. One of the identities that comes from what's called a double angle identity is this thing right here. The sine of 2x is equal to 2 sine x cos x. So we're using that identity for this equation, because for us to solve it, we're going to need to use that identity. So you need to look for opportunities for where this is going to come up. So let me go back to where we were. Here's our derivative. Here's where we had the sine of 2x right there. And we're just going to replace the sine of 2x with 2 sine x cos x. And again, that's just a trig identity. And why is that useful? Because no, right, this minus 2 is no longer an issue. Why? Because I can just divide both sides of this equation by minus 2. And then that 0 divided by minus 2 is still 0. So no real need for us to do that there, right? So now we have this, right? How does this help us? Can anybody see a reason? Can anybody see a way that this could help us to actually solve for, solve for x? Right? It says cosine of x plus 2 sine x cos x. Does anybody see how? What do you think my next step is going to be at this point for me to solve this? Anybody? I want to solve for x here, folks. And it says cos of x plus 2 sine x cos x here. Think back. Thank you, Kushi. Right? Think back to when you were solving trig equations. That's why you learned all of that in the previous course. Right? And that's why that's a precursor to this course. Factor out the cosine of x. So if I factor the cosine of x, which is the common factor between both of these, I get the cosine of x times 1 plus 2 sine x equals 0. Does that step make sense? Let me check in with everybody on that. Anika and Braden, does that step make sense? Let me start with Anika. Anika, does factoring out that cosine of x make sense to you? And Braden, how about you? Does that step make sense to you as well? Braden, are you there? Factoring out that, okay, great. So now, you see, that's why, and we did this when we were doing other kinds of derivatives and setting it equal to 0. If we can factor it, then we can try this zero product law, because no, I can say that the cosine of x is equal to 0 is 1 solution, or one way to get the solution. You're going to get x prime of that. And again, where is the cosine of x, excuse me, equal to 0? We're going to get to that in a minute. But that's when x is equal to pi over 2 and minus pi over 2. That's both of these are within the range of what we're talking about here. But the other one is this one here, where 1 plus 2 sine x is equal to 0. Therefore, sine x is equal to minus a half. And you know how I do this? X prime is equal to the sine to the minus 1 of a half, which is pi over 6 and, sorry, minus 5 pi over 6 and minus pi over 6. So these are all of the various angles that we need, right? Now remember, I can only get to these angles here. Let me point something out to you. Even though, and I know that I might be going a little bit too fast on this, so hold on. Even though I am talking about minus pi to pi, I can't get to these going in a pi direction. I can't get to these two angles. Why am I using these two angles down here? I'm using these two angles because it says the sign is negative, and where the two places that sign are negative are in quadrants 3 and 4. That's where sign is negative. So that's why I'm putting my pi over 6, which is what the sine to the minus 1 of a half is, in those two quadrants. Okay? And in this quadrant, and in this quadrant, I can get there by going a minus direction. I can get there by going in this direction, right? So to getting in this direction is going to be minus pi over 6 and minus 5 pi over 6. What I'm doing is I'm doing this and getting here. Then I'm also going here to get to the other angle over there. All right. So these are all of my possible, I'm going too fast again. These are all of my possible values. The two endpoints, minus pi and pi, and then the ones that we got by doing the sine to the minus 1 of a half, which is the minus 5 pi over 6 and the minus pi over 6, the minus pi over 2 and the pi over 2. These two come from where the cosine of theta is equal to 0. And those are the two angles that make sense for that. Where's cosine equal to 0? At pi over 2 and at minus pi over 2. Those are both within the domain that we talked about. So here are my answers. These are the y values that come out of that. The maximum y value is 1.5. The minimum y value is minus 3. Okay? All right, let's move on. Cosine x plus sine x. And we're going to go from 0 to 2 pi. What's the highest value within that domain? So let's go ahead. Find the derivative. Minus sine x plus cos x. Okay. So that means that cos x minus sine x is equal to 0. Now, how would I solve that? Right? Well, first of all, we can do this. We can say cos x equals sine x. We can do that. Any suggestions as to how I can solve this now? I can't factor anything. Right? Does anybody have a recommendation as to how we might be able to solve this? Where is cos x equal to sine x? Between 0 and 2 pi. Does anybody know an approach we can use to solve for that? Anybody? Nobody. How about if we did this? Remember, we can do the same thing. Nobody have any ideas as to how we can figure out where cosine of x is equal to the sine of x, right? Cosine in terms of sine. Are you talking about using one of those co-functions? Is that what you're thinking of, Koshi? The co-functions. And of course, I probably would want to use pi over 2 minus x rather than 90 minus x. I know what you mean, Kushi. Those are the co-functions. That's one way to do it, right? And I'm glad you raised that. But there's another simpler way that I can show you. Does anybody have an idea of what that is? Kushi is right, by the way. That would work. That would absolutely work. We could do that. Change sine into cosine, change cosine into sine would work. But there's a simpler way to do it. Can anybody think of what it is? And I'm glad Kushi at least had an idea, which is one way, right? So that's one way to do it. Well, how about this? How about if I divide both sides by the cosine of x? Look what happens if I divide both sides by the cosine of x. Cosine of x divided by the cosine of x, sine of x divided by... Remember, I can do the same thing on both sides. That's typically how we solve an equation. If I divide both sides by the cosine of x, one side becomes 1 and one side becomes a tan of x. Right? That's what sine of a cosine is. So the question now is, the prime of tan to the minus 1 of 1. So if I were to draw a grid, I'm talking about in the first quadrant, because that's where tan is positive, and in the third quadrant. And the angle that's going to be measured is going to be the angle again to the x-axis. And that angle, in case you don't know it, is pi over 4. Those are the two angles that give me a tan of 1. So what's the angle in the first quadrant? Well, the angle in the first quadrant would be just simply pi over 4. What's the angle in the third quadrant? Well, that's 5 pi over 4. So I now have 4 angles to contend with. The two ends, 0 and 2 pi, and then the pi over 4 and the 5 pi over 4, the two that are also when tan is equal to positive 1. So I'm just going to evaluate those. I get these answers. So it means that my max is 1.41 and my min is minus 1.41. How did I get the 5 pi again? Okay, you mean 5 pi over 4. It's not just 5 pi over 4. Thanks for the question, Ashvan. Again, Ashvan is doing what I want you all to be doing, which is ask when you're not sure. So one of the angles is in the first quadrant, which is pi over 4. The other angle, to get to that second angle, Ashvan, I'm going to start from here. I'm going to go past pi. Remember, this is pi over here. And I have to go another pi over 4 to get to where I want to get to. So take that pi and add on that pi over 4. And that actually gives you 5 pi over 4. You can check that for yourself. Does that make sense, Ashvan? All right. So that's where that second one comes from. This all goes back to solving trig equations, which again is something we should have done. And I know it's been a while for some people. Excuse me. This all goes back to being able to solve trig equations. I know techniques like this one, which is where you have to divide both sides by cosine. And by the way, again, what Cushy suggested would also have worked. These are things that you have to try and figure out as you move along, as you go along through this. Determine the local maximum point on the curve y equals 2x minus tan x between minus pi over 2 and positive pi over 2. Similar question again. So we only want the maximum point this time, not the max and the min, not the extremes, just the max point. And the function is 2x minus tan x. So here we go. The dy dx of that is 2 minus secant squared x. So we're going to take that, set that equal to 0. Same thing all over. And by the way, just remember that the derivative of tan is in fact secant squared rather. So that's why I did that. So here's what I need to figure out. Where is the secant squared of x equal to 2? Well, the next step is to take the secant squared and make it into 1 over cosine, which I've just done, right? And then I'm going to say, flip the two sides over. So what I've done is I've taken the reciprocal of the two sides. So secant squared x is 1 over cosine squared x, right? Then I'm going to take the 1 over cosine squared x and flip it upside down, right? Take the bottom, put it on top, take the top, put it on the bottom, which means I'm going to end up with cosine squared x. But if I flip the right, I also have to flip the left. And that 2 becomes 1 over 2. So now we're saying cosine squared x is equal to a half. Okay, that means that the cosine of x is equal to the square root plus and minus of 1 over 2 or 1 over root 2, which means that we're talking about the cosine to the minus 1 of 1 over root 2 plus and minus. And that means I'm going to be in all 4 quadrants. Because I said plus and minus, it means that I now have to find that angle in all 4 quadrants. And I can tell you, if you put that on your calculator for 1 over root 2, you should get pi over 4. And that pi over 4 is in all 4 quadrants. And again, always measured from the x-axis. Always measured from the x-axis. So here are my potential values of x. There's minus pi over 4 and there's plus pi over 4. The only thing is that I can only get to the angles in this quadrant and this quadrant. I can't get to the angles over here. Why? Because this thing says you can only go between minus pi over 2 and plus. So I can only go as far as here, and I can only go as far as here. That's it, right? The minus pi over 2 means I do a half, or actually a quarter turn this way. Uh, that's what pi over 2 means. Pi over 2 is right up here. And the minus pi over 2 means I can only do a half turn or a quarter turn this way. So to get to those, I can only get to I can't get to these angles over here. Can't reach them because it's outside of my domain. But I can get to this angle, and I can get to this angle. That's why the minus pi over 4 and the plus pi over 4 are the only two that matter to us right now. So I'm going to go ahead and evaluate the two boundaries, the minus pi over 2 and the positive pi over 2, and the minus pi over 4 and the positive pi over 4. And I put those into the original function. They're giving me infinity, and then the minus 0.57 and the positive 0.57. So it does mean that the local max occurs at the pi over 4, which is at okay, hang on one second here. Undefined. It means it's undefined, as I should say. So I shouldn't say infinity, it's actually undefined. So the pi over 4, which is the one over here, gives us a positive 0.57. It's undefined at these other 2 points when you put that back into the original equation, because the tan of minus pi over 2 is undefined. Put it on your calculator, it's going to blow up. Same thing for pi over 2, that's going to be undefined. That's why I put infinity here, because it's undefined at those 2 points. You might be thinking that infinity is more than these, but it's just undefined is what this really means. So these are the two actual values that you should have for y. And the one that is the higher one is the 0.57. And hence that is where your local max is in that particular region.